Hello and welcome to C++ Weekly. I am your host, Jason Turner. I'm available for code reviews and on-site training. If you have not had me out for training to your company, I want you to know that my focus is on best practices. This is generally what I want to do, is teach people how to write code that is safer and faster by default. That might sound like competing things, but trust me, if you rely on your compiler, then you can get code that is very efficient and also has as many compile time checks as possible. So be sure to contact me for more information about that. This episode, I'm going to pick up exactly where I left off on the last episode, talking about C++ 26's CNTTP bind front for callables. I'm going to show you approximately how this was implemented, and we are going to go ahead and show a way to take this a step further. This is approximately what this code looks like. They do more complicated things than this, but this is the magic of lambdas, and lambdas are amazing, and we can do so much with them, we may as well take advantage of them. So I'm going to go ahead and remove the std : there, and I'm just going to put bind front. I expect this to compile. It did. It's going to generate approximately the same code. It does. Yay. That's all good. Now, they do other things in here. Mine only works with free function-like things. It doesn't work with number functions. That's fine. I would need to use standard invoke to get the same behavior here, but I am choosing not to do that in this case. So we have our first template parameter. That is the callable thing. Now, note, I don't have to capture the func, and if you watched any of my previous episodes on that topic, then you can go back and reference them or something. I don't have to capture a constant expression in a lambda expression. And there's bugs and clang in this particular regard, as we probably saw in the previous episodes on that topic. So I am passing the func in here. I don't have to capture it. And then I have some sort of parameters that want to be bound. They're taken by forwarding reference, and I capture them all in a forwarding kind of way. So I'm taking ownership of them, moving if I can, copying otherwise. And then I've got the explicit set of template parameters that are my actual lambda that is now going to be returned. So note the return statement here is generating a lambda and returning it. The return statement on line 12, this is the body of said lambda. So this thing bound on line 21 is the closure object that is the result of the lambda expression. So now this thing bound has a call operator, and that call operator knows how to call func. Okay, very good. So the thing is, 1 here is a compile time known constant. And this makes me wonder, why stop at 1 parameter? Why stop at just the function? Why not let me bind as many things as I want to at compile time? Let's just call these constexpers. I don't know. It's a terrible name, but let's go ahead and call them constexpers. We're going to expand out the list of compile time known parameters, then expand out the list of runtime known parameters, and then expand out the list of parameters that are actually called when we invoke the bound object. Let's go ahead and see if we can observe this. Now, note this 1 being copied onto the stack here. This 1 is the value 1 down here. Let's go ahead and make that a 3, if you will. And yes, we can see the 3 here. This 3 is going on the stack. This is the closure object itself. It has this value 3. Let's go ahead and move this here. And I just saved an extra part of the stack because I don't actually need to use any stack space here. I can now make that first parameter, the 3, part of the type. And I think I can even go one better. If the size of runtime known parameters is 0, which it is in this case, then I can make the Lambda itself static. This is also a C++ 26 feature that I have done an episode on. So I no longer need to bind these parameters. I no longer need to expand them here. And I can now declare the Lambda itself static, which I believe goes here. Okay. So I can now also save potentially some stack space by making the Lambda itself static in the cases where it can be. This is where it's actually making the call operator on the Lambda static. Now I'll observe that it didn't actually change anything in this compiled code, which is slightly disappointing, but oh well, that's not the point. I can now say that this is a function that takes 0 parameters and is basically always going to return the value 6. That's pretty neat. Unfortunately, I can't quite see the result of all of that in here. So this is my argument that perhaps the authors of this feature should have taken it one step further and allowed us to bind as many things as possible at compile time that are known. Yeah, you can see even in a debug build that those two values are just simply part of the type. We never see them being passed anywhere because they're part of the type, as is the actual call to add. Well, I titled this episode Zero Cost Bind or something like that, Zero Cost Bound Functions. I hope you found this interesting, maybe inspired you in some of your own code. Thank you for watching this episode of C++ Weekly. Be sure to subscribe. Catch you in the next one.